In this video, we're going to prove the alternate segment theorem. So what we do in a question like this, we first label our triangle. So let's call this point A. We call this point B. Call this point C. Let's call this point D. And let's call this point E. Then we're going to mark the center of the circle. And then I'm going to draw in the radius here. And draw it again here. So we've got two radii of a circle. Now what's going to happen is OB is exactly the same as OC because they're both radii of a circle. So let's write that down. OB equals OC. Why? Because they're radii of a circle. So that implies that triangle BOC is an isosceles triangle. And we know that the base angles of an isosceles triangle are equal. So what we first do, we say let this angle between the chord BC and the tangent DE, let's say, this angle is going to be called X. So let's tell the examiner that. Let angle, let's name it CBE, CBE be known as X. And then we can state another well-known circle theorem here. And that is that the angle between the radius and the tangent is 90 degrees. Well, OB is the radius and BE, for example, is our tangent. So this whole angle must be 90 degrees. So let's whack that in. The angle between the radius and the tangent is 90 degrees. Is 90 degrees there. So what we need to do in this question is say, well, what's going to be this small angle here? So let's mark that in so we can visualize what that angle is. I'm going to do it in purple. So what is this small angle? Well, if this big angle is 90 and that's X, surely this little angle must be 90 minus X, which is the angle OBC. Now, the angle OCB, as in this angle, is the same exact because it's the base angle of an isosceles triangle. And we know the two base angles of an isosceles triangle are equal. So now that we know that they're both 90 minus X, that will enable us to work out the angle at the center. Well, we've got a triangle there, and we know that all the angles in a triangle add up to 180. So we're going to do 90 minus X plus 90 minus X. And that's going to give me 180 minus 2 lots of X. So we need to take 180 away from all of this angle. So be very careful with the algebra here. It's going to be 180 minus 180 minus 2x. So we end up with 180 minus 180. But minus times a minus is a plus, so we end up with 2x. 180 minus 180 is 0, and we're left with 2x. So we can say that this angle at the center is 2x. Well, we know it's the angle at the center, and we know a well-known circle theorem that the angle at the center is twice the angle at the circumference. So it means that this angle must be x. So let's write that down. So the angle at the center is twice the angle at the circumference. So we said that angle BAC is x, so we can say angle BAC equals x, and that's exactly the same as angle CBE. And there we go. We've proved the alternate segment theorem, that the two angles are both x.